Okay, guys, ready? You have a little plane on one of those aircraft carriers. It's like a big boat. Ever seen those before? The big boats that have the planes on top of them? An aircraft carrier. Yeah, like in the city, there's a famous one that's called the Intrepid. And basically, it's a big boat. And on the boat, there's actually a short little runway. And planes actually take off and land on the boat. It's called an aircraft carrier. Okay? You with me so far? But the thing is, the runway is kind of short. So the plane can't take off with its own engines because it won't be able to get up to speed fast enough in this particular problem. So they say there's two things going on. The plane's engine itself thrusts it forward. The plane jet engine itself pushes it forward. But there's also a cable that's hooked to the front of the plane, and this cable pulls the plane forward to give it a boost, to get it going fast. And so there's a forward force. They say it's a steam-powered catapult. So the plane takes off on top of this boat. How does it take off? Two ways. One, it has its own jet engines that push it forward. And two, there's some kind of like catapult that like slings it forward. Okay? So the question wants to know, how much work is done by that catapult? That's the main question. In other words, this force right here, due to the catapult, the question is, how much work does that force do? With me so far? Okay. So if I take this point over here to be my initial point, and I take this point over here to be my final point where the plane takes off, I can do that work-energy theorem, and I can compare the energy at one point plus the non-conservative work to the energy at the other point. So basically, I write out the big jalopy equation here. Kinetic energy initially plus gravitational potential energy initially plus any potential energy stored into a spring initially plus any non-conservative work done. Remember, non-conservative work done, that's the work done by things other than gravity, other than spring forces, equals the kinetic energy at the final point plus the potential energy due to gravity at the final point plus any stored up energy in a spring at the final point. Now, are there any springs in this problem? No. So basically what we could do is cross these two out. If I call this altitude right here ground level, basically, is there any gravitational potential energy involved? No. Now, what can we assume the initial velocity is over here at the initial point here? It's 0. You can assume that the plane starts from rest. And if the plane starts from rest, I don't think they directly tell you that, but you can kind of read into it that it's going to start from rest. Then what's the deal here with this initial kinetic energy? 0. So what it's going to boil down to is the non-conservative work, the work done on that jet plane, is going to be equal to the gain in the kinetic energy. But the tricky thing is, this non-conservative work, it's done by two different things. So this non-conservative work is going to be the work done by the jet engine plus the work done by the catapult. And that's going to equal the final kinetic energy. So this right here is the sum of the so the non-conservative work is the sum of the work done by the engine and the work done by the catapult. Okay? Now, they tell us that the kinetic energy at liftoff is 4.5 times 10 to the 7th joules. So I'm going to make some room up top here. They tell you in the problem that the kinetic energy at the liftoff is 4.5 times 10 to the 7th joules. And they tell you the thrust of the engine. So remember back over here, we had the force due to the engine? Yes? Well, this right here, the work done by the engine, that could be replaced by the force exerted by the engine times the distance of the runway. Plus the work done by the catapult. And in the problem, they tell you the force due to the jet engine is 2.3 times 10 to the 5th newtons. And they tell you the length of the runway, 87 meters. So now you have every single thing you need to solve for the work done by the catapult. How much? The one thing I wanted to emphasize, I don't think I emphasized enough, is that with I erased it, but with that formula, KE plus PEG plus PES plus work done non-conservative equals KE plus PEG plus PES. That non-conservative work, many times it could be like a group of different works added up. You know, like in this last case, it was the work done by the engine, and it was the work done by the catapult. In another homework problem, that non-conservative work was the work done by the engine plus the work done by friction. Now, in that other homework problem, where the non-conservative work was equal to these two, the work done by the engine, that was positive work, and the work done by the friction force turned out to be negative work. And the two of them gave you the total non-conservative work. So the point I'm trying to make is, this non-conservative work done could be a bunch of different works added up. Okay? So your final answer is 2.5 times 10 to the 7th joules.